Hello, boys and girls. Welcome to today's lesson, remote learning lesson. And today we're going to do a quick review of graphing functions. Now, throughout the semester, we have taken our parent functions and we have transformed them left and right, up and down. We've vertically stretched them. So you should be familiar with this. Today, we're going to look at the exponential function. And once we've done a few, I'm hoping that it becomes apparent how to transform them, and then you're going to complete this pair deck activity. So that's our goal for today. All right, so we're going to start by looking at our parent function, which is y equals 2x. That is our parent function. So we're going to do y equals 2, and then to do raised to the x, we have to do the a to the b form, and then press x. And that is what an exponential function looks like. I want you to notice a couple of things about this exponential function. It's an always increasing function. And remember when we talked about rational expression, we talked about an asymptote. I want you to notice that this has a horizontal asymptote. And in this case, this horizontal asymptote is approaching 0. So remember, we write a horizontal asymptote as y equals 0. And after this, we're going to refer to this as HA. The other thing I want you to notice about a exponential function, that notice it goes on and on to the left. And if we go to the right, it goes on and on. It's just getting bigger and bigger and bigger. So it's up at 45, 75. So it's going on and on in both directions. So we say that its domain is negative infinity to infinity. Now that is the domain for all exponential functions. All exponential functions have a domain of negative infinity to infinity. And the next thing we want to look at is the range. So remember, the range is the y value. Notice that it goes down to 0 and then goes back up, and it never goes past 0. You can kind of see that blue line. It's never going past 0. So it has a range, and this time the 0 is not included, so it's got a range from 0 to infinity. Okay? All right, and so that's pretty much what you're going to do today. So we're going to just kind of graph them and talk about how they moved, what happened with them. So I just want to do one more with you, or a couple more with you. So let's say we have 2x, 2 to the x plus 3. All righty. Now, what did we notice about that? Notice how our horizontal asymptote changed. Our horizontal asymptote moved up 3 units. Okay, so remember, oh, I did the wrong one. Well, I'll just rewrite it to make it right. It's 2x plus 3 on the outside. So recall from what we've done in the past, moving by adding something on the outside is going to move it up or down. So in this case, it changed the horizontal asymptote that is now y equals 3. And that corresponds to this 3. Our domain is going to remain the same. And our range changes based upon our horizontal asymptote. So since our horizontal asymptote is 3, that means our range is 3 to infinity. Okay? Let's do another one where we have the, we change it. This is like a parenthesis. Okay? So knowing what we know about if we put something in that parenthesis, what's going to happen to it? So we're going to say 2 to the parenthesis x minus 4. So what do you expect to happen to that from all the problems that we've done in the past? What do you expect to happen? Okay, we should expect that that moved it 4 units to the right. Let me graph the parent function so you can see that easier. Okay, so the red is the original, and you see that it moved it 4 units to the right. Okay, and we would expect that. Notice the horizontal asymptote remained y equals 0. Our domain is always negative infinity to infinity. And our range, therefore, is 0 to infinity. Okay? And this last one, without graphing it, and that's kind of what I want you to be able to see. Without graphing it, I can see, because I'm adding 1, that my horizontal asymptote is going to be y equals 1. My domain, it doesn't matter how I move that graph. It's always going to be negative infinity to infinity. And this will change my range. So my range would go from 1 to infinity because of my horizontal asymptote. But if I wanted to ask you how it moved, we would say moved left 2 and up 1. Based on all the things that we've done this year, we can say that that moved left 2 and up 1. All right, so what I would like for you to do is to complete this pair deck. I'm grading this pair deck on accuracy, so make sure everyone does it and you'll get a grade for it. It is really easy. It's just a matter of graphing it, the parent function, and then graphing the original function and see how it changed. You'll probably, after about the third one or even after the second one, won't even have to graph the original, and you should be able to tell me that it moved left, moved right, and what the horizontal asymptote is. Okie dokie? All right, boys and girls, I will see you Monday. Have a great weekend.